Imagine that tomorrow, every zero on Earth simply vanished. The money in your bank account would change overnight. Computers would stop working. The internet would cease to exist. Almost every modern calculation would collapse. The strange part is, for most of human history, people lived exactly like that. Without zero, how did humanity build pyramids, map the stars, construct great cities, and trade across continents without ever knowing what zero was? Or perhaps, the more astonishing question is, why did something that seems so simple today take thousands of years to be discovered? We often think zero is just a number, but it isn't just a number, it is an idea. And that idea once left the entire world completely puzzled. What did the first humans count with? Imagine you're living 30,000 years ago. No paper, no pen, no numbers, not even the concept of mathematics. And yet, you still need to know how many animals remain in your herd, how many people are in your family, how many animals you've hunted, and how many days remain before winter arrives. So, how did the first humans keep track of it all? The answer is, they didn't begin with numbers. They began with their own bodies. Their 10 fingers were the world's first calculator. Each finger represented one item, one animal, one person, one object. And when 10 fingers were no longer enough, they reached for small stones. Each stone stood for something: an animal, a successful hunt, or an important memory they couldn't afford to lose. Archaeologists have even discovered ancient animal bones covered with carefully carved marks. The most famous examples are the Ishango bone from Africa and the Lubambo bone, which date back tens of thousands of years. Many researchers believe these engraved lines represent some of humanity's earliest counting systems. Those marks weren't decorations. They were something far more important. Perhaps the very first notebook ever created by human hands. Every line recorded a memory. Every notch represented a quantity. People also carved marks into pieces of wood, into stone, into almost anything that could preserve information. This was a time when counting didn't mean writing a number. It meant recording the world, using the simplest symbols imaginable. But then, everything changed. Villages became larger. Communities grew from dozens to hundreds, and eventually to thousands of people. The stones were no longer enough. The carved marks were no longer enough. Humanity needed an entirely new way to count an entire civilization. They had numbers, but they didn't have zero. Then, villages became cities, and those cities grew into great civilizations. Ancient Egypt, Mesopotamia, to home. They built monumental structures, collected taxes, measured land, predicted the flooding seasons, traded across vast distances, and governed tens of thousands of people. All of it required numbers, and they did have their own number systems. The Egyptians used special symbols to represent sure, ibai, i10. The Romans created the numerals I, V, X, Ezen, number, D, and M. The people of Mesopotamia developed one of the most sophisticated number systems of the ancient world, based on base 60. But there was one very surprising fact. None of these civilizations had the number zero, as we understand it today. And that's the first big twist. They could calculate, they could keep records, they could build wonders that still amaze the modern world. Yet somehow, they accomplished all of it without zero. So, how was that possible? The answer is surprisingly simple. They only wrote what actually existed. If there were 3 sacks of grain, they wrote 3. If there were 10 cattle, they wrote 10. But if there was nothing in a particular place, they usually left it blank. And that empty space sometimes created a serious problem. Imagine trying to tell the difference between Yi, Yi, and Yi without a symbol to show that something was missing in between. As long as calculations were relatively simple, this wasn't a major issue. But as civilizations expanded, trade became more complex, and astronomy demanded greater and greater precision. That empty space became a real obstacle. Humanity had already built massive pyramids, tracked the movements of the stars, created powerful empires. But one tiny idea was still missing, a symbol that didn't represent an object, didn't represent a quantity, but instead represented nothing at all. And it would take hundreds more years before one civilization would dare to transform nothing into a real number. What happens when there is no zero? At first, living without zero doesn't seem like a very big problem. After all, people still built cities. They traded, collected taxes, observed the stars. Life went on. But the deeper historians looked, the more they realized that the absence of zero was one of the greatest limitations of ancient mathematics. Imagine trying to write the number 1005. Today, it takes only a few digits. But before zero existed, it became far more complicated. Numbers grew longer, harder to read, harder to record. And with just one mistake, an entire calculation could change completely. But the real challenge wasn't simply writing numbers, it was place value. Today, we instantly understand that in the number wu bai ling wu, both fives look exactly the same, yet they don't mean the same thing. The first five stands for 500. The second is simply 5. The zero, sitting quietly in the middle, holds each digit in exactly the right place. Take that zero away, and 505 becomes wushawu. The value changes completely. That was the problem ancient civilizations struggled with for thousands of years. They knew how to count. They knew how to calculate, but they had no symbol to say there is nothing in this position. And that was the great paradox of civilization. Humanity was brilliant enough to build magnificent wonders, skilled enough to predict the movements of the stars, powerful enough to create vast empires. Yet all of them were still missing one tiny symbol that could complete their entire number system. Then, somewhere else, in another part of the world, someone began asking a question no one had ever truly asked before. If one can be a number, then could nothing also become a number? The idea of an empty space, then, around 4,000 years ago, in the ancient land of Mesopotamia, a remarkable idea began to emerge. The Babylonians, among the greatest astronomers and mathematicians of their time, noticed a problem. How could they tell the difference between two numbers when there was nothing? In the middle, they didn't invent the number zero. Instead, they created a small symbol, a simple mark, to show that this position was empty. And that is the next big twist. For the first time in human history, people weren't just thinking about what existed. They were beginning to think about what was absent. But here's the important part. That symbol was not a number. The Babylonians didn't add it. They didn't subtract it, multiply it, or divide by it. They used it only as a placeholder, a marker that prevented confusion when writing numbers. In other words, they had come astonishingly close to discovering zero, but they still hadn't crossed the final line. It was like discovering fire without yet knowing how to keep it burning. The idea of nothing had appeared, but no one had yet dared to say that nothing could itself be a number, and it would take nearly 2,000 more years before, in another civilization, a mathematician would propose an idea so unbelievable it would transform the course of human history. He made a simple claim: nothing is also a number. The birth of zero, then, between the 5th and 7th centuries, in India, a revolutionary idea was born. At first, it sounded almost too simple, but it would become one of the greatest breakthroughs in the history of human thought. This was no longer an empty space, no longer just a symbol. To avoid confusion, it became a number that represented nothing. And this was the moment the world changed. Indian mathematicians, especially Brahmagupta, treated zero as a true part of the number system. For the very first time, nothing was no longer simply an absence. It became a value, a number with its own place, its own rules, a number that could take part in mathematical calculations. It was an entirely new way of thinking. Until then, people had only counted what existed. 1 cow, 10 sacks of grain, 100 people. Now, they could also count what did not exist, an idea that sounded almost impossible, yet it opened the door to an entirely new era of mathematics. Because of zero, the place value system finally became complete. Large calculations became faster, more accurate, and dramatically simpler. One tiny symbol could completely change the value of every digit beside it. But here's the surprising part. Even after zero had been born, the world wasn't ready to accept it. In many places, people believed the idea was simply too strange to be true. When zero conquered the world, but even the greatest invention can never change the world if it never spreads. From India, the idea of zero traveled alongside merchants, scholars, and explorers into the Islamic world. In Baghdad, during the Islamic Golden Age, mathematicians did more than simply accept this new number system. They expanded it, refined it, and helped unlock its true potential. Ancient manuscripts were carefully copied, translated into Arabic, then carried across the Middle East, through North Africa, and into the Iberian Peninsula. That journey became the bridge that brought zero to Europe. But here's another surprise. Not everyone welcomed it. To many people, the idea of a number that represented nothing felt strange, too abstract, even suspicious. Many merchants still trusted Roman numerals. They believed the new symbols were too easy to alter and could make fraudulent bookkeeping much easier. In several medieval European cities, the use of Hindu-Arabic numerals in certain official commercial records was temporarily restricted or even prohibited because authorities feared forgery and confusion, not because zero was dangerous, but because it was new, too different. History shows us that almost every world-changing idea is met with skepticism, and zero was no exception. But over time, its advantages became impossible to ignore. Calculations became faster, trade became more accurate, astronomy advanced further than ever before. In the end, what had once been dismissed as meaningless became the foundation of modern mathematics. And from that moment on, one tiny symbol quietly began reshaping the future of human civilization. The invention that changed the world. But the biggest twist isn't that zero made counting easier. It's that it transformed human civilization itself. The moment zero became part of mathematics, everything began to accelerate. Algebra flourished. Complex equations could finally be solved. Astronomy reached levels of precision never seen before. Then, centuries later, came the computer. At first glance, every computer seems unimaginably complex. But deep down, at its very core, every computer understands only two states: on or off, 1 and 0. The entire internet, your smartphone, GPS, satellites, airplanes, banking systems, artificial intelligence, even the video you're watching right now, every one of them is built from billions of binary digits made up of just E and 0. Take away either one, and the digital world simply falls apart. What's truly remarkable is that a symbol, once dismissed by so many people, has become the universal language of every modern machine. Perhaps no invention has ever been so quiet, yet so powerful as zero. Because if the wheel gave humanity the power to move, then zero gave civilization the power to advance. And maybe that's the greatest surprise of all. One of the most important inventions in human history began with a symbol that represents nothing. It's hard to believe that one tiny symbol could reshape the entire course of human history. But that's exactly what happened. Without zero, there is no place value number system. Without a place value system, there are no efficient, accurate calculations. Without those calculations, there is no algebra. Without algebra, there is no modern physics. Without modern physics, there are no satellites. Without satellites, there is no GPS, no computers, no internet, and no modern world as we know it today. What's astonishing is that it all began with a single symbol that represents nothing. Perhaps humanity's greatest invention wasn't the wheel or fire or the pyramids. Perhaps it was an idea. The idea that nothing could be represented, could be calculated, and could become the foundation for creating everything. Because sometimes the inventions that change history aren't the ones we can see. They're the ones that change the way we think. And maybe the greatest secret behind human civilization never truly began with the number one. Maybe it began on the day someone dared to turn nothing into a number.